Greetings and welcome, friends. Mr. Wada here. Me and my friends in real life, my geometria class, we're taking a look at section 5.7. We're talking about using congruent triangles. So notice with this example, I'm not setting out to prove that triangles are congruent, but if I knew that triangles were congruent, it might give me said ability to prove some additional pieces of information. All right. This whole section is something you've already been using a handful of times. So maybe it'll be a nice, just like, all right, refreshing look at some additional problems using congruent triangles. And the way we use them is with CPC-TC. Corresponding parts of congruent triangles are congruent. So let's take a walk through this little problem here. It says, explain how you can use the given information to prove that the hang glider parts are congruent. All right, so given information, I've got angle 1, which is an exterior angle, is congruent to angle 2. All right, and I know that angle RTQ, this angle right here, is congruent to RTS, real-time strategy games. Probably my favorite kind of video games, to be honest. Turn-based, it's up there as well. So let's see, RTS. Wow, now I'm just reminiscing of wonderful real-time strategy games. So let's see, so I've got my givens. All right, gimme. And let's see, what else do I know? I know, anyone see other information that might be helpful? Reflexive, what's the reflexive? All right, RT is congruent to itself. I like that. RT is congruent to itself. So I've got an angle, I've got a side. What else do I have? Let's see, I think I can say that angle RQT is congruent to angle RST. All right, this angle and this angle are congruent. I'm arguing that this angle and this angle are congruent. I believe the theorem, maybe you can look me up on this, but congruent supplements theorem. Does that sound familiar? Right? Two angles that are supplementary to the same angle or two congruent angles are going to be congruent to one another. So I believe I can now say that triangle, I guess I'll just use the naming convention I did here, RQT, is congruent to triangle who now? RST. I did happen to label that in an appropriate way that it'll work for my triangle congruence. And the reason those triangles are congruent is why now? Why? Angle, angle, side. It's a non-included side. So angle, angle, side. As a result, I actually now know a whole bunch more information. I know that TQ is congruent to who now? TS. And why do I know those are congruent? Because of CPC-TC. Corresponding parts of congruent triangles are congruent. I know that segment RQ is going to be congruent to RS. Why is that? Because of, I'm going to write it again. I'm not even going to use the ditto marks. We should probably get practice with it. CPC-TC. Corresponding parts of congruent triangles are congruent. And what's the last piece of information that I can claim, although they actually didn't ask for it? Yeah, they just asked about glider parts, and this angle technically isn't a part. But QRT is going to be congruent to angle SRT by the CPC-TC. Corresponding parts of congruent triangles. Let's see, I need like a quad angle mark there. Yeah, I can't fit that. 1, 2, 3, 4. 1, 2, 3, 4. There we go. And so once I know triangles are congruent, I can now make claims about all of the previously unknown parts of those triangles. All right, you guys like that? Are you feeling it, Mr. Krabs? Are you feeling it? Yeah. Yeah, you guys got this. Right, so this is just going to be like a nice, like, refreshing walk back to the Shire from Mordor as we're just proving things about triangles. So now, if I want to prove these angles are congruent, don't look so much at the angles, but look at the triangles. All right, let's hit my given information. I think, I gave you guys this problem, I believe, right? It's on your paper, on your packets. Oh, yeah. Good job, past self. High five. So let's see. AD is congruent to CD. AB is congruent to CB. I've got two sides. What else could I do? Reflexive with the who now? Man. BD is congruent to itself. Reflexive property of congruence. I think those triangles are congruent, and that's going to help me prove that its angles are congruent. So let's see, I'll call that triangle ABD is congruent to which triangle? Is it CBD. KBD. All right. The reason? Why are those triangles congruent? Side, side, side. Right? You guys with me on that? You agree? Right? You guys are experts at proving triangles congruent now. Now that those triangles are congruent, does this help me prove this? Angle A is congruent to angle C? I believe so. Why is that true, Aiden? Yeah, you can tag team a friend into the rink. No. Tag him in. There we go.
CPCTC.
CPCTC. Man, good teamwork. All right, CPCTC. If the triangles are congruent, then its corresponding parts are congruent. Notice, nowhere in the instructions did it say, you should probably prove these triangles are congruent. It was asking you a completely unrelated question. What you have to realize is that you were able to use congruent triangles to prove more things about this. Let's jump into example 2 here. Oh, more rivers. Oh, guys, man, I wish I was out kayaking the rivers these days. I haven't paddled too many rivers ever since I've started having kids and didn't have health insurance for a little while.
Mr. Waddy, it is so cold outside. Don't go near water.
Actually, a wonderful thing about white water in the winter is if the water's moving, it can only get so cold. It's like 32.5 degrees. It won't get any colder than that. If the water's moving, the friction between the molecules are keeping it warm enough that it can't drop below freezing.
The air is really cold, so the water.
That's true. Hypothermia is a concern.
Yeah.
But I've been there. I've done that. No, just mild, super mild. I've fallen in ice water in rapids by myself, and I live to tell about it. But yeah, water can only get so cold. If you add salt and ice to it, you can get it maybe down. I think it 26 degrees or whatever. Yeah, but you're good. You're good. So it can only get so cold. Let's see. Use the following method to find the distance across a river from point N to point P. Place a stake at K. All right, near. Let's see. On the near side. All right, that's easy. All right, Isaiah. So we're placing a stake right here. All right. And then let's see, find M the midpoint of NK. So here's where I was going to cross it, and then I would find the midpoint and label that somehow. And then from K, walk perpendicular into the forest here, apparently. That might be difficult with the obstruction of view, until you can look through M and see your original landmark on the opposite shore. All right, so you'd be looking this way. That you would be looking past whatever marker you have here, that would be hitting, right, the landmark that you were trying to cross to. All right, so you find a point that is collinear to M and P, right, which is actually the way they phrase it right there. Explain how this plan allows you to find the distance. Well, first of all, we know that these triangles, how are we going to prove these triangles are congruent? Well, these two are congruent by def of MP. If these are perpendicular, they are right angles by def of right angle. We'll label some of this, I guess. So we'd have, what do I have? I'll say NM is congruent to KM by def of midpoint. Good times, good times. I'm going to say that the classic angle N and angle K are right angles, which is def of perpendicular lines. I'm going to say that they're congruent to each other. Right? We've done this so many times now. We're getting used to it, I hope, though. Right? I'd hope so. So angle N is congruent to angle K. Sorry, yes, by right angles congruence theorem. Right angles congruence. And what else do I know? I can, oh, vertical angles. Who's the verts?
LMK and PNN.
Angle PMN, yep. By the vertical angles theorem. So those are congruent to each other. I'll label them with red. It'll show up. Look at that. Ooh, sweet. And I think these triangles are congruent. You guys think so?
Yeah.
Let's do the same naming convention as that angle we just did. Angle. So triangle LMK is going to be congruent to triangle PMN. Why are those congruent? Angle, side angle. And that helps us because now I could measure out LK. I could say that LK, let's see, LK is congruent to PN, right? L and K were in the first and last positions there, so PN there, because I did scroll down past my drawing. By CPCTC, and then I could say that their measures are equal, that LK equals PN by def of Cong. Right? So that's similar to the first exploration that we did when we were exploring ways to find the distance across a river. Right? And that helps us because I can measure this, which is on land, assuming I have the ability to travel across land, and I have minimal ability to travel across rivers. All right, cruising right along. We're doing it. We're doing it. Here we go. Example trace. How are you guys feeling with proofs? Like scale of 1 to 10, where are we at? Like we're getting there though, right? Like we've come a long way, friends. Come a long way. Planning a proof involving pairs of triangles. Use given information to write a plan for a proof. Okay, so we don't have to like formally write it all out. Let's see, given angle 1 congruent to angle 2. Cool. Angle 3 congruent to angle 4. Nice. Prove triangle BCE. So I'm going to end up proving these guys. Oh, this is such a good problem. Guys, you didn't even see this one coming. This is so great. Is congruent to DCE. Let's see. Wow. What are you guys thinking? What's some valuable information? I'm assuming we've got to use some CPCTC here. What are your guys' thoughts? Let's see, BE is congruent to BE. Yeah, they're suggesting CE as well. Now that is true, but which triangle is that working me towards? I would need to get a statement saying these two are congruent to help me out. But yeah, CE is congruent to itself by reflexive. All right, all right. Let's see, so that's congruent to itself. Now for that triangle, I've got an angle and a side. If you can show that this is congruent to that, I'd have a side angle side, right? If I could get that far. But I don't know that yet. But check this out, friends. You all ready for this? What if I could prove something about, let's see, I'll do, what if I could prove something about the big triangles first? Right? If I could prove those two purple triangles are congruent, I would then know that those are congruent by CP/CTC. Let's work towards proving the purple triangles congruent. So pretend the rest of the sketch isn't there for a moment. How could I prove the purple triangles are congruent? Right now I have an angle and an angle. So I'm already, I just needed a side. Reflexive on who? CA to CA is congruent, right, to itself by reflexive. Angle, side, angle. The side was in the middle of the two angles for any one of those given triangles. So let's see. So I can say triangle CAD is congruent to triangle CAD, so CAB, yeah. And that is true by angle, side, angle. Now that I know that, check this out. I can say this is congruent to that. CD is congruent to CB. Why is that true, friends? CBCTC. Corresponding parts of congruent triangles are congruent. And so by using those bigger purple triangles, I've now proven a piece of information that will help me prove something about these smaller yellow triangles. That's crazy, friends, isn't it? Let's see, do I have enough information to prove the yellow triangle's congruent? Yeah. I think so. What information do I have for the yellow triangles? Side, angle, side. It's an included angle. Side, angle, side. Makes sense. Just makes good sense to me. All right. Let's get example 4 in here. I don't know which ones I'm skipping on your end there. But I think that example 4 is worth pointing out because we've been doing constructions as though they've been true without trusting, you know, like for valid reasons that they've been true. All right, so check this out. All right, write a proof to verify that construction for copying an angle is valid. All right, so it's kind of hard to see what's going on. So the angle that we're copying is angle BAC, or angle, right, A, if you want to call it that. And if I want to copy this angle down here, I don't know if you guys remember the way we would do that, but you would create a swipe, right, in which this is congruent to that, and this is congruent to that. You guys agree? Right? So we'd make that swipe, right, because we'd start with this given information here, right? We'd draw a new segment, and I draw a swipe. But now I've got to figure out where does this go? You guys remember how we would do that? We wouldn't use a protractor.
What?
We'd use a compass. If I used a compass and measured from here to here and like swipe arced, right, and then placed it at this first intersection and swipe arced, the intersection between these two arcs would be a point that is the same distance out here, and these two are congruent to each other because those were congruent radii on our compass swipe. So how do I know that these two triangles are congruent to each other? Why are those two triangles congruent? What information have I labeled on those triangles? Side, side, side. And since those triangles are congruent, I can now say that angle A is congruent to angle D. Why? If the triangles are congruent, then its corresponding parts are also going to be congruent. CPCTC. You guys remember doing that? It's been like a long time. We're on day 38 of the course, by the way. Good times, good times. All right, so thank you for watching, internet friends. Have a great day. Bye-bye.